All right, so what we're going to be doing today is we're solving quadratic equations using the quadratic formula. All right, so when we look at this, remember that we have a generic form of a quadratic equation, y equals ax squared plus bx plus c. So what we're going to focus in on are these letters. A is attached to the x squared term, b is attached to the x, and c is the constant, it's by itself. So on this, the process that you're going to do is the very first one is you're going to determine and list out the values for a, b, and c. So look at the x squared term, that's your a. The number in front of your x, that's your b. The number without a variable, that's your c. The next thing you do is you plug it into the quadratic formula. The quadratic formula is listed here on the screen. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, there is a song to help you memorize that. It goes to the tune of Pop Goes the Weasel. So if you just look at that, I'm going to sing it through once for you so you can kind of hear it. If you practice that song a couple times, you will easily have this formula memorized. The song goes like this. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. That's how the song goes. So it just helps you memorize your formula. Now, once you do that, once you plug those values in for a, b, and c, you simply work out the equation. If the radical is not a perfect square, then you're going to simplify the radical if possible. If the radical is a perfect square, then look to simplify the fraction. If it's not a perfect square, then you're going to write it both as a simplified radical and as a decimal. Okay? We also have this other piece over here to the side. And if you notice, that is pointing to this portion under the radical, the radicand, the b squared minus 4ac. That is what is called the discriminant, and it tells me how many solutions we will have. So if the discriminant is a positive number, the radicand, if it's a positive number, you are going to have two solutions. If the radicand is equal to 0, then you are going to have one solution only, because plus and minus 0 doesn't do anything. If the radicand is a negative number, you're going to have no real solutions, okay? Because we can't have the square root of a negative number in the real number system, okay? So we use the discriminant just to take a look at things and make sure what's going to happen in the problem. All right, so I start off and I look at my problem here. And I start off and I say, okay, what is A, B, and C? So A, remember, we look in front of x squared, and that would be a 1. B, we look in front of x, that's 5. And C is the one by itself, which would be negative 36. So now what we simply do is we plug this into our formula. So x equals negative of b plus or minus the square root of b squared minus 4 times 1 times negative 36 all over 2 times 1. Okay? Now at this point, we start working it out. Negative of negative 5 is just a negative 5. Plus or minus, now you're going to take your calculator and simply press 5 squared minus 4 times 1 times negative 36, and you're going to get 169. And then that is over 2 times 1, which is 2. Now, we know that 169 is a perfect square, and that is actually 13. So now what we have is our two answers. I have negative 5 plus 13 divided by 2. Well, negative 5 plus 13 is 8. 8 divided by 2 is 4. So there's one of my answers. My second answer is x is equal to negative 5 minus 13 divided by 2. So there, negative 5 minus 13 is negative 18, divided by 2 is negative 9. Okay, so that is how we do the quadratic formula. All right, let's try this second one here. So I have 6x squared minus 11x minus 7. So A is 6, B is negative 11, and C is negative 7. So now we go to plug it into our formula. So we go negative of negative 11b plus or minus the square root b squared minus 4 times 6 times negative 7 all over 2 times 6. Okay, so now we start to work that out. Negative of negative 11 makes it positive, plus or minus. So now we take our calculator and we simply go 11 squared minus 4 times 6 times negative 7. And we end up with 289. So we have the square root of 289. And then 2 times 6, that's going to give me 12. Okay? So now we look at that and we check, is the square root of 289 a perfect square? And it is. It is 17. Okay? So we're going to change the square root of 289 into simply a 17. So now we go back. Now we're going to finish it up. So we go x equals, we have 11 plus 17 divided by 12. So 11 plus 17 is 28. Right? So we have 28 divided by 12, and you look at that and you say, okay, what goes into those two numbers? And that would be a 4. 4 goes into 28 7 times, 4 goes into 12 3 times. So my first answer is 7/3. Then I come back and I say, okay, x equals 11 minus 17 divided by 12. 11 minus 17 is negative 6 over 12, which is negative 1/2. And that's our second answer for that problem. Okay, so let's keep going. Let's try the next one. So on number 3, we start off again. A is 6, B is 4, C is 3. So now we go to plug it in. So x equals negative of b plus or minus the square root b squared minus 4 times 6 times 3 all over 2 times 6. So negative of 4 is negative 4 plus or minus. Now you take your calculator and you're simply going to go 4 squared minus 4 times 6 times 3. And we end up with a negative 56. And that is over 12. Now we can stop right here. And my answer is going to be no real solution. Now, the reason it is a no real solution is when you look at the problem, when you look at your quadratic formula, right here, it's a negative inside the radical, which causes it to be a no real solution. Okay, let's try here, number 4. So we start off, we have an A at 9, we have B is at 6, C would be 1. So now we take that, we plug it in. So x equals negative of b plus or minus, and then it's the square root of b squared minus 4 times a times c all over 2 times a. So we start to work this out. Negative 6 plus or minus. Now we punch that in, so we go 6 squared minus 4 times 9 times 1, and we get 0. And that is over 18, 2 times 9. The square root of 0 is indeed 0. So all of this is gone now. So what we're left with then is an answer of negative 6 over 18, which would simply be negative 1/3. And that would be the only answer that we would get because my discriminant, because the value under the radical is a 0. Okay? All right, let's try these last two then. So we look here on the first one. I have A is 8, B is 12, C is negative 1. Okay, I take those and I plug them into my formula. So x equals negative of 12 plus or minus the square root of 12 squared minus 4 times 8 times negative 1 all over 2 times 8. So we start in, negative of 12 is just simply negative 12 plus or minus. We take our calculator now and we go 12 squared minus 4 times 8 times negative 1, and we get 176. And that is over 16. Okay, now we take a look at 176, and let's try some different numbers here. If we look at 176, it is divisible by 4, but I think there's something bigger. So if we keep going, I'm going to divide it by 16. There it is. So 176 can be divided by 16 times 11. And the square root of 16 is going to come out to the front. So what that's going to end up giving us is this. We're going to have negative 12 plus or minus 4 square root of 11 over 16. Now, what's important about this is we take a look at these three numbers right here. They're all outside of the radical. And we ask ourselves, does 12, 4, and 16 have anything in common? And the answer would be yes. So we simplify those. So I'm going to take and I'm going to divide them all by 4. So negative 12 divided by 4 is negative 3. Four divided by 4 is a 1, so I'm not even going to write it. Square root of 11. And then 16 divided by 4 is 4. This is my simplified radical answer. Okay, so this is my simplified radical answer here. Okay, now we're going to take and find our two decimal answers. Now, remember, we were working on it the other day in class. What we're going to do is we're going to type the entire numerator in, and then we'll do the division. So I'm going to go negative 3 plus square root of 11, and it should have come out to be 0.3166, and then we're just going to hit divide 4, and that's going to give me 0.079, and we're going to go to the hundredths, so that 9 would make it go up to an 8. Then I'm going to use my up arrow. I'm going to come over to the minus, plus, I'm going to change it to a minus, which gives me negative 6.31, divide 4 again, and I end up with negative 1.58. And those would be my two decimal answers for that problem as well. Okay, let's try number 6 here. So we start off, A is 11, B is negative 10, C is negative 5. So we start to plug these in. So we go x equals negative of negative 10 plus or minus the square root, -10 squared minus 4 times 11 times -5 all over 2 times 11. So now we start to break that down. Negative of -10 is a 10, plus or minus the square root. So now we take our calculator and we go 10 squared minus 4 times 11 times -5, and we get 320. And that's going to be divided by 22. So now we look at 320 and we're trying to find what goes into it. So I'm going to start at 64, and 320 divided by 64 is 5. So what that means is I can rewrite this to say 64 times 5. The square root of 64 is going to come out here. So what we get then is we have 10 plus or minus 8, the square root of 64, times the square root of 5 over 22. Now, remember, just like on the last one, we look at this number, the 8 and the 22. So the 10, 8, and 22, and we simply ask, what do they all have in common? And it would be a 2. So 10 divided by 2 is equal to 5, plus or minus 4. 8 divided by 2 is 4, square root of 5. And then 22 divided by 2 is going to give me 11. So that is my simplified radical version. And then I'm going to take and I'm going to punch it into my calculator now. So I'm literally just going to go 5 plus 4 square root of 5 equals, and that should come out to be 13.9 something, divided by 11. And that gives me 1.267, so we're going to go 27. That 7 would make the 6 round up. Then I come back and I go 5 minus 4 square root of 5 equals, and that's negative 3.94 divided by 11, and that's going to give me negative 0.358, so we're going to round that up to 36. And that is how we do the quadratic formula.